right, I think that's better. Let's go ahead and get started. I am going to work backwards because I really want to go through the last questions first because you guys did so well on part 1, that first page, that I'm okay if we don't get to those first 3, 4, 5 questions. You guys did insanely well on them, so I'm okay. So I'm working backwards. As of right now, I am going to skip the first extra credit question because it is a little bit on the lengthier side, and there was a shorter question inside the test that we can go through together if we get to it. I'm going to start backwards. This is, I don't know, there's 2 different versions. So if I'm not writing down the question that you have, I'm just doing the other version. The other version is going to be posted on Google Classroom because I did it with the other class. So on question number 2, this was an extra credit. It's asking you to find all, keyword here is rational, zeros. So when it's asking you to find all rational roots in zeros, what that means, ooh, it's a little blurry. There it goes. What that means is you're going to first check if you can factor. If you cannot factor, then we got to use the rational root theorem. The silly snake. Let me check if I have my exposure up. I do. It's a little not clear to me. It's okay. All right. One of the first things I noticed you guys forgot. What is step number 1 always? GCF. Y'all be forgetting GCF. Okay, so GCF we have is x. We got an x, an x, an x, an x, and an x. Pull that x out. That means we got 7x to the 4th power minus 5x to the 3rd power minus 9x squared plus 5x plus 2. Because you have an x out in front, this is your root of 0. So it's like it's in a secret bubble. So when you go like all the way at the end to see what your roots are, this right here should be a root of 0. So I'm noticing some of you not bothering to write things down. Please make sure you write things down. I do know what your grades are and how you did on the last test. So I encourage you to write this down because you will see it once again tomorrow. I'm also going to expect you not to eat in my classroom because we do have roaches and that's not okay. Okay, now that that's out of the way, let's check if we can factor. I got 1, 2, 3, 4, 5. We got 5 terms. Unfortunately, factoring does not work with 5 terms that we are aware of. So we have to use the silly snake. Take the tail, place it over its head, and we got 2, 7. That means our possibility for 2 is 1 and 2. Our possibilities for 7 is 1 and 7. List them out. The way that I like to list it is I start with the first numerator over all denominators, then the second numerator over all denominators. So far, from what I see, you guys can list out your possibilities. It's the steps after that that gets confusing. So for our possibilities, we got a plus or minus 1, a plus or minus 2, a plus or minus 1/7, and a plus or minus 2/7. This right here is not your rational roots. These are your possible rational roots. It's like saying, for example, it might rain tomorrow. Like, how will I for sure know if it rains tomorrow? Well, I'm going to get to tomorrow, and I'm going to live through tomorrow. I'm going to check if it rains. So same thing here. These could be your zeros. These could be your roots, but we have to go and check them in order to make sure if they actually work or not. So these are your possible rational roots. Step number 2 is to take your factored form, and I like to leave space, or I like to leave a bubble anywhere I see an x. And we're going to check to see which one of the possible roots makes the whole equation equal to 0. This is where you need a calculator. If you don't have a calculator, please go get a calculator. Is it -1? Someone already called it out, -1. Thank you. Now I could waste my time and check that right now, but we can check using synthetic. Just one. Oh, just one. Does -1 work too? Oh, I don't know. Oh, okay. Well, let's check using synthetic. +1, let's check using synthetic. If it works, great. If it doesn't, we'll know that something went wrong. Bring down the 7. 7 times 1 is 7. Add those together. We got a +2. 2, we got a, what is that? -7. Thank you so much for helping me out. -7, add those together. We got a -2, -2. Boom, that does work. We are happy. Happy, happy, happy. Again, we are adding in the middle. You guys are pretty good at that. And then we are multiplying on the outside. Let's write out what we have left over. Here's r, here's 0, here's 1, here's 2, and here's 3. So we got 7x cubed plus 2x squared minus 7x minus 2. And I'm getting a little happy because I see a 7, 2, and a 7, 2. So I think we can factor by grouping. Let's check. Out of these two terms, I can pull out an x squared. We got a 7x left over plus 2. And out of these two terms, I can pull out a -1, which leaves us with 7x plus 2. We have an x squared and a 1, so x squared minus 1. Please don't multiply those together. Just write them exactly how it is. Just copy and paste x squared, copy, paste, -1. Same thing with here. We got 7x plus 2. Now remember, when you are grouping, you see it twice, you write it once. It is the same thing, so it only occurs once. This is specifically to factor in by grouping. This right here are factors. It is not asking you for factors. This is asking you for roots. So to go from factors to listing out your roots, you're going to set each bubble equal to 0, and you're going to solve. Now this guy right here can be factored further. So if you saw that it can be factored more, that's great. If you didn't, you could have gotten away because it's not asking for factors, it's asking for roots. And I'll show you how. We're going to add 1 to both sides here. X squared is equal to +1. I'm going to take the square root of both sides, which means, don't forget this part, you have a plus minus in front of that square root now. So that means x is equal to plus minus 1. Now, if you didn't do this and you saw the factors, you could have had x minus 1, x plus 1, and then set each one of those equal to 0 and solve. So there's two ways of doing it. Yeah.
Would I have gotten a different answer if I had synthetic instead?
Nope. The answer is going to be the same because it either works or it doesn't. Yeah. Okay, so we got these roots right here. And then we got a -2, -2, 7x, -2, divided by 7, divided by 7. X is then equal to -2/7. Okay. All right, be careful. This is where your final answer, you got to I want to say breathe. Like just take a moment, breathe it out, and see what we have. We have two roots right here. This is a root. This is a 0. We have one root here. We have, when we did the synthetic division, another root here of +1. And because we factored out an x, that means we also had a root of 0. So how does the answer look like? I have some space here randomly, so I'm going to write my answer box here. So for our answer, I had a 0 that was a root, I had a 1 that was a root, I had a +1 that was a root, I had a -1 that was a root, and I had a 2/7. If you gave me this answer, I accepted this answer. However, 1 occurs twice. So if we wanted this in the correct format, then you need to write 0, 1 multiplicity of 2, -1, -2/7. Theoretically, the order doesn't matter as long as the 1 multiplicity of 2, that has to be together. This right here in pink, that is your answer. Yeah.
Why do you have to have both 1 and have 1 twice?
So do you remember we were talking about the fundamental theorem of algebra that says the quantity of roots has to match up with the exponents that you have? So if we have an exponent of 5 and all of our roots are rational, there's no like complex or imaginary ones, then we need to have a total 1, 2, 3, 4, 5 because our exponent is 5. Now that could be including a complex or imaginary one, so be careful on that. We'll also talk about behaviors literally like in 2 days. We'll talk about the behaviors of what a multiplicity behaves like in a graph. Okay, so that was question number 2. Let's talk about extra credit question number 3. Now, a lot of you for extra credit number 3 went halfways, but the directions always messes you up. So question number 3 for extra credit is asking you to write a polynomial function of least degree with integral coefficients that has the given zeros. One of the given zeros is 3 plus I. One of the given zeros is a root 7. So immediately, I'm going to highlight this in 2 different colors to indicate this right here is 1 root. This right here is another root. 3 and I do not get separated out. It's one thing. The only time things get separated is if you have a comma. The comma is separating 3 plus I, and the comma is separating with the root 7. Okay. GR, can you do me a favor and close the door, please? Both of them, because it's going to get loud here in a minute. Our red flag is this I, and our red flag is this square root. Anytime you have an I or a square root, a conjugate occurs. Meaning we have a 3 minus I and a minus root 7. That also exists. So if we are listing out our roots, we now have a total of 4 roots. 1, 2, 3, 4. Because we have a total of 4 roots, when we multiply everything out, the highest exponent has to be 4. So if you multiply everything out and you get a highest exponent of 3 or 2, something went wrong. So for this question, for question number 15, and for question number 11, the steps are going to be the same. I encourage you to do a row and column thing. I'm going to rewrite my roots. Then I'm going to write out my x minus. And the x minus represents the quote-unquote opposite of what we see. So that's where the x minus is coming from. Then I'm putting in another parenthesis in here. And a lot of you did this step correct. You just kind of gave up halfway. 3 plus I, 3 minus I, root 7, and negative root 7. This negative gets distributed onto that 3 and I, onto that 3, onto that negative I, onto that 7, and then we got 2 negatives here that make a positive. So our factors are now x minus 3 minus I, x minus 3 plus I, x minus root 7, and x plus root 7. So these right here, I'm not even going to bother to rewrite it. These are your factors. Okay? Set it equal to p of x, and you got your answer for question number 11, the format. Obviously, the numbers are going to be different. However, this is not asking for factored format. This is asking for, let me go back, it's asking for of least degree with integral coefficients that has to give in zeros, meaning expand. If it's not saying specifically factored, you have to expand. This is how you expand. Take the two factors that you got from your conjugates. So since we had two conjugates, here they are. And you're going to do box method for both. You don't have to do box method, it's just the one that makes the least mistakes. X minus 3 minus I. X minus 3 plus I. So that's our first one. Our second one will be x minus root 7 and x plus root 7. And we're going to multiply that out and see what we get. I'm going to switch to pencil because I don't want to accidentally make a mistake. So that way I get to erase. So we got x squared. Here we got negative 3x. Here we got negative ix. Negative 3x. Here we got a positive 9. Here we got a positive 3i. Here we got a positive ix. Here we got a negative 3i. And here we have, this one's fun. Do you see how we have a negative I and a positive I? I'm going to break it down. This negative I is like negative 1 times I. This positive I is like saying positive 1 times I. So when we're doing this, we're saying negative 1 times 1 times I. So what we're really saying is negative 1 times I squared. But what is I squared? Negative 1, good, negative 1. So what is negative 1 times negative 1? Positive 1. Let's move on to the next one. We got x squared. Squared. We got a negative root 7x. You can put x in front. Doesn't really matter because they're conjugates. Things are just going to cancel out here in the middle. And then again, it's like saying negative 1 times root 7 times root 7. So we got negative 1 times, what's 7 times 7? 49. What's the square root of 49? Oh, 7 times negative 1? Negative 7. Bless you, my child. Okay. What's really fun is this part. Things just cancel. I feel like that's the best, for me personally, it's the best part. Like you do all this work and you just get to like toss it out. So you get that and that crosses out. That one and that one crosses out. These two need to be combined, not canceled out. And then I'm going to highlight the 9 because it's just a number and a 1 because that's just a number. So on this one here we have x squared minus 6x plus 10. This right here is a factor still, so it still needs to be in a bubble. This one here, cancel. X squared minus 7. Again, these are factors. The question is not asking you for factors. The question is asking you for expanded form. It's asking you to write everything out. So that means we got to do box method one last time. So let's do box method one more time. Does anyone still need this on the board? Going once. Going twice. Let's do it one more time. So we got x squared minus 6x plus 10. And we got, what do we got? X squared minus 7. We got x to the 4th power. We got negative 6x to the 3rd power. We got 10x squared minus 7x squared. What is this? Positive 42. Is that 42? Yeah, thank you. And then negative 70. Anything canceling out? No, but I do see we need to combine the 10 and the negative 7 because both of them have an exponent of 2. So we have x to the 4th power minus 6x cubed plus 3x squared plus 42x minus 70. Now the original question, let me look back, did not have a equal sign. It is, however, asking for a polynomial function, so you have to make that equal to p of x, f of x, 0 something, because it's asking for an equation. So this right here would be your answer for question number 3 on the extra credit. Yes, sir. Yep, absolutely. This one here? You just needed me to see it? Or do you have any questions on it? Take a moment and let me know. Yes, sir. Go ahead, Jay.
So your answer, you had it all equal to p of x.
Uh-huh.
Does it have to equal to p of x? Or?
P of x, f of x, 0. I'm okay with any of it because it is asking for a polynomial function. It means that it wants an equation. If you just leave it just randomly, it's just floating numbers in the air. We got to catch them all. Yes, sir. Go ahead. Why are both the 3's negative? Oh, because when you take a conjugate, so back up here, when you take a conjugate means only flipping the sign in the middle. So our 3 remained positive like our original root that was given. The I stayed I, except this right here, the plus, became a minus on the conjugate. So when we, in this step, distributed the negative, that negative went on to a positive 3, and this negative went on to a positive 3, making a negative 3 for both. Okay. Go ahead and flip backwards. We're going to look at question number 15. I will be skipping question number 15. It is identical to what we did a few moments ago. The only thing I want to note on question number 15, please write this out. Regular numbers do not have conjugates. If we have time, I would love to go back to that, but let's see if we can get everything else done first. This one right here does have a conjugate because of the square root. Anything time you see a square root, a cube root, with anything, conjugate, and then you have an I that also has a conjugate. So the conjugate here is 1 root 7. That doesn't change. The only thing that changes is the symbol in the middle, in this case minus. So we have 1, 2, 3 roots total. So your highest exponent on this one, when you expand, should be an exponent of 3. Okay, let's go ahead and work on number 14. Number 14 is asking you to find all zeros. Now I did type in a little hint for you there, which means find all the rational and the complex. So number 14 had the equation of f of x is equal to x to the 4th power plus 4x cubed minus 5x squared minus 20x. And right when I was writing that, saying that, I noticed that every single term had an x. Step number 1 is what? GCF factor. That means we have an x. So that means I have x to the 3rd power plus 4x squared minus 5x minus 20. Now because we had this pulled out x as a GCF, keep in mind that 0 is a root. Literally, it's 0. And a lot of you forgot about your zeros, your x's. From here, I'm itching for grouping. If you can do it, factor, it's a lot easier, faster. If you can't, use the rational root theorem and just start plugging in numbers until you can factor. Because I'm thinking x and x squared, and there's a 20 and a 5. So let's pull out of these two an x squared, leaving behind an x plus 4. And then from these two, let's pull out a negative 5, leaving behind an x plus 4. Again, because these are the same, we're going to write them once. which means we have an x plus 4. Here we have to write them together. Don't multiply anything with the x squared. Just copy and paste exactly what you see. These right here are your factors. It is not asking for your factors. It is asking for your roots, your zeros. So we need to convert your factors into roots by setting it equal, both of them, to 0 and solving. So I'm going to do one and then I'm going to do the other. I'm going to add 5 to both sides. So I have x squared is equal to 5. Then I'm going to take the square root. And anytime you take the square root, remember you have to add that plus or minus in front of the square root symbol. So we have a plus or minus here. X is then equal to plus or minus the square root of 5. This one right here is your root, or 0. We still have the other one to do, which was the x plus 4. Set it equal to 0, subtract 4, x is then equal to negative 4. That is one of your roots. So then the answer is asking you to list all of them. It doesn't have to be just rationals, whole numbers, fractions. It can also be complex, like square roots and i's. So our zeros are 0, negative 4, plus root 5, minus root 5. Now if you choose to write plus or minus instead, that's fine. I understand. So these are your all roots. So that was number 14. Number 12 and 13, they went together. On number 12, there was a typo. It had the same answer twice for B and D. It ended up being the right answer. So if you selected B or D, you got the credit for it. So I'm going to do 12 and 13 combined because 12 feeds into number 13. Does anyone still need 14 on the board? Going once. Going twice? Yeah, okay, that's fine. Go ahead. For everyone else, go ahead and take a look at number 12 and 13. And I'm going to write it out here in just a little bit so that way we can move forward. Yes, ma'am.
Can I go to the bathroom? I got this one right.
Yeah, that's fine. Okay, so number 12 is asking you to do the possible zeros. Yeah, go quick. Okay, you ready? Silly snake. 2 over what? What's in front? What's the leading coefficient here? 1. Thank you. We got 2 over 1. Does anyone still need the previous number 14? So before I cover it? Going once? Going twice? Okay. 2 over 1, which means I have a plus or minus 1 times 2 and plus or minus 1. So that means happy dance. The only possibilities we have are whole numbers, 1, 2, either a positive or a negative version. These are your possibles. Now for number 13, it's asking you which ones actually work. So we have anywhere you put a X, you're going to place a bubble, I call them. And you're going to check which one does give you a 0. Anyone who got that question right, what was a 0? Shout it out for me, please. Negative 1. Okay, so let's do negative 1. So negative 1, let's check by synthetic division, a negative 1. So I got a 1, a 2, a negative 1, and a negative 2. Be careful with this, there is a 1 here. Double check that really quickly. I'm going to bring that down. That's a negative 1, a 1, a negative 1, a negative 2, a positive 2, and a 0. Yes, it does work. Happy dance. We're going to work backwards. So we got 0, 1, and 2, which means we have x squared minus x minus 2. Can we factor this? Two things that multiply to a negative 1 but add up to a negative 1. What did I say? Two things that multiply to a negative 2 but add up to a negative 1. 1 and 2, which one's negative? Is it the other way around? Positive 2 or negative 2?
You wrote the equation on.
I did?
X squared plus x minus 2.
Oh, thank you. Okay. So now I 100% agree with you. Positive 2 and a negative 1. Again, these are your factors. It's not asking for your factors, it's asking for your zeros, your roots. So your roots are setting each one of those bubbles equal to 0 and solving. Now again, I don't need to see your work for that. If you can mentally see opposite of what I see is my root, that will help you out, especially in Unit 2 when we go into graphing polynomials. But if you need to set it equal to 0 and solve, that's fine. Okay, so we got a negative 2, we got a 1, and this one right here using synthetic division is also a root. That's the one that worked here. So we have 3 roots. Here's our answer. These are all rational, no complex. So we got negative 1, 1, and negative 2. The order really doesn't matter. Usually we do smallest to largest, but I'm noticing it didn't work. So the answer was C, right? C. Okay, so we did 12, 13. Let's go ahead and flip it over. 11 is the same exact way that we did the extra credit question. Just stop where it says factored form. Stop at your bubbles. That's the key word. Let's go ahead and do question number 10. It's asking you to factor. So it's not asking for roots, it's asking you to factor. Does anyone need this before I removed it? Because I kind of moved that quickly. Okay, so this one is asking you to actually factor. I feel like all of them were asking for roots. This is the different one. F of x is equal to 3x cubed plus 7x squared plus 5x plus 1, and I'm doing a little sad face in my heart. No GCF. I'm also noticing 3, 7, and 5, and 1. There's nothing that I can pull out. So since there is no GCF and I cannot factor by grouping, I have no choice but to use the rational root theorem. So rational root theorem is the silly snake. We're going to take that 1, we're going to put it on top of 3. 1 over 3. So that means we have 1, that's it, that's all we got on top. And we got plus or minus 1, plus or minus 3 on the bottom, which means I have a 1 over 1, or I have a 1/3, which means I have a 1 or 1/3. Obviously, I'm taking a little extra steps here to write it out as 1 over 1. You don't need to. These are your possible factors. We don't know which one works. Step number 2 is to write this out with a bubble in place of x, so that way we can check. Is that a plus 1? What did I circle? Yeah, plus 1. And which one does work? Negative 1. Perfect. So much faster when you guys just give me the answers. I like that. Okay, let's check synthetic division. We got a 3, a 7, a 5, and a 1. Bring down the 3. Negative 3. What is this, 5? Negative 5. Is that right? It's 4. I got overly excited. I got overly happy to do some synthetic division. And then we got a 1 and a negative 1 and a 0, and yes, we are happy. Do you see I gave this one a nose? Silly. R, 0, 1, and 2. We have 3x squared minus plus, I almost did the same thing, 4x plus 1. Now, we can check if this one factors. If it does, yay. If it doesn't, we continue plugging in numbers to see which ones work. So I'm going to switch to pencil and I'm going to check if maybe the rainbow method can work.
Yes.
It does? Good. So we got x. Give me a quick second to write this out and then you can tell me what my answers are. X plus 3, x plus 1. Ooh, actually, I want to take a moment, you guys. I saw some weird things when you guys were doing rainbow method. When you are here at the rainbow method, and I know it sounds silly and I'm still going to say it, these two right here are fake. These do not exist. These are fake. You made it up. You did that. Nowhere in there did we actually have something that was x squared plus 4x plus 3. That's fake. Doesn't exist. So So these two factors don't exist. These are not real. These are, I can't even say imaginary because we're working with eyes, but these don't exist. So you have to undo what you did. So since you multiplied by 3, you have to come back here and you have to divide by 3. Not only do you have to do that, you still have to simplify. You're in IM3, beautiful people. So if you see a fraction that can be simplified, you simplify that fraction. So we got x plus 1, and we got 3x plus 1. These are your factors. Now we are doing a happy dance because it is asking for factors. So we got these two factors, and don't forget this -1 that you got from synthetic division here. And we're going to do opposite of what we see, so we're going to add another 1. Now, if you gave me the, did we have a GCF? No, okay. If you gave me this answer, I checked it off, yes, it was okay, you're fine. However, that is incorrect in format. Because you have x plus 1 twice, x plus 1 squared, 3x plus 1, and the original question had the format of f of x. So therefore you need to set it equal to f of x. Otherwise it's just random bubbles blowing around in the sky on your paper. So the one in black is the one that's more correct. However, I did accept the one that's in pink and red. Okay, that was number 10. Continuing to work backwards, I'm going to skip to number 7. That's the one that I saw that gave everyone a hard time, number 7. Anyone still need this on the board? Going once, going twice. Okay, number 7. That's been doing that. Just like we have a Casper in here. I don't know if you guys noticed, but we have Casper the ghost opening and going through all the doors here. Okay, so we have 81 minus 24a cubed. The a cubed is kind of like your q, right? It's kind of like, hey, perhaps you're doing something with a cubic. The only thing is 24 is not a perfect cube. 81, maybe, but I think 81 is squared. So we need to see if there's a GCF that can come out. Anyone can help me with the GCF? 3? Okay. What is left over? 27 minus 8. Beautiful. Thank you. Anytime you have a cubic, take a look at that cheater board. I'm not going to remove it for tomorrow. It is there for you. That means you have to use your formula. We have a cubed minus b cubed. Get it into that formula and just plug numbers in the correct spot. What cubed is 27? 9? 3. Like that would have been. Okay, and then what cubed is 8a cubed? 2a cubed. That means your a is 3 and your b is 2a. Looking at the formula, you have a difference of cubes. A is always before b, so AB, AB, AB. This a right here is squared, put it in a bubble. This b right here is squared, put it in a bubble. Then you go back and you say always same, always different, always positive. Plugging in your numbers, we have an 3 minus 2a. Then we have inside a bubble 3 squared plus 3 times 2a plus 2a squared. Close it up. One last time, we got 3 minus 2a, 9 plus 6a plus 2 times 2 is 4, a times a is a squared. Don't forget your GCF. A lot of you did the step. You removed the GCF. You just forgot to put it in your answer. Don't forget in your answer. And this is your factored form. That was number 7. Does anyone like to see, would anyone like to see 6, 8, or 9 before we move on? Which one? 8. 8, okay. Okay, number 8 says x to the 4th power minus 8x squared minus 9. Now, originally when I brought this to your attention, we used the u substitution method. It is your choice whether or not you want to use u substitution. I personally do not. It confuses me, even though it is my job to present that to you. I personally don't like it. I noticed that this is a quadratic, 4 and 2. So I'm going to ignore the 4 and the 2, and I'm going to treat it as if it were a quadratic. It is a leading coefficient of 1. What two numbers add up to a negative 8 but multiply to a negative 9? Negative 9 and positive or negative? Positive. Okay. Then we go back and we notice, hey, we had an x to the 4th power. So I cannot just leave it as x. I have to leave it as what? X squared. Okay. Now, I have binomials that have an exponent of 2. It's not linear, meaning I have to look at my cheater board and see if any of them can factor. An exponent of 2 means I need to see if it can be a difference of squares. It's in the name. Difference of squares. Do you see this plus? It ruins life for you. It's no longer a difference of squares. If it was a minus, whoo, that would be fun. But it's not. So this one right here is done. You can't do anything with it. Difference of squares. Do you see this minus? Ooh, happy dance, maybe. Can we write this in the format as something squared minus something squared? Yes. Okay. So what squared is x squared? X. What squared is 9? 3. So if you're looking at the cheater board I'm pointing at to right now, it's that very top one that says x minus 3, x plus 3. That means that you no longer have this feller. He's gone. That's gone. You have factored it to be more factored, therefore the originals are not there. So your answer for number 8, x minus 3, x plus 3, those two can be switched if you need to. It doesn't matter. X squared plus 1, you are done. Hey, I think that kind of rhymed. Yeah. 8. It will be posted on Google Classroom. It will be posted. If we have time, sure, absolutely. So I want to make sure, because last period I focused on the other version. This period I want to focus on this version, so that way y'all have both online. Okay, any other ones? Anyone on 9 or 6? 9 or 6? 9 or 6? Going once. Take a look. Which one? 9. Okay. Number 9. Number 9 says 6x squared minus 17x plus 12 is equal to 0. And our goal, what does it say? Factor. Factor completely. Okay. With this 17, can't really pull out a 6. So we don't have a GCF. Bummer. We have an x, no x. Still no GCF. Bummer. The only method that we have that we can use is the rainbow method. So here are your clouds, here's your arc. So we have x squared minus 17x. What is 6 times 12? Is that 72? 78 or 72? Okay. Just want to make sure I'm writing it correctly. Again, if you can come up with a better word than fake, temporary, not part of your answer. Okay. What times what is 72 but adds up to negative 17? I know someone did it. Help me out. 9 and 8. Both negative. Again, fake. Not part of your answer. Not real. Imaginary. Temporary. Don't leave that as your answer. You got to take that cloud that you are floating on and you got to divide by it. Now, I saw something silly. I saw people leaving it like this. 2 hiccups. 1, you're in IM3. Fractions, they can be simplified. Okay? Simplify your fractions. 2, bring out the denominator. So simplify first, bring out the denominator. Nick, you doing okay? Nicholas? You doing okay?
Yeah.
Okay, just making sure you're okay. Okay, so let's simplify it. 3 goes into 9 3 times. 3 goes into 6 twice. Then we got what? 2? 2? Yeah. 2 goes into 8 4 times. 2 goes into 6 3 times. And now that you've dealt with that cloud you were on, it's no longer fake. Now we're in reality. 2x minus 3, 3x minus 4. And this right here is your factoredness. If you had a GCF, bring it out. If you don't, don't. Yes, sir, go ahead.
Could you real quick go back to 8?
Real quick, go back to, yes. Did I do something wrong?
No, I just want to check.
Okay.
Oh, thank you.
Uh-huh. Okay. Any questions on page 1? Y'all did really good. Yeah, which one? Can I leave the other one on?
No, can you do the other number now?
The other number 9. I have the 8 and the 9 done on the other video. If we have time, I will go back to it. I promise. If we have time. Anything on page 1? Or I will start doing the other version. Going once? 5. Yes. Number 5 is asking for divide. 4, 3, 2, 1. And I gave it to you in standard form? What? Okay. 21a to the 4th minus 19a cubed plus 44a squared. 25a minus 22. I'm actually really surprised. I don't think I was supposed to give it to you in standard form. I did it? On that one? Oh, okay, well the other one got lucky. Yeah, that's fine. Okay. 7a right here. And this 21a to the 4th, they get divided. You guys can't see that. Let me try again. (21) divided by 7 is what? 3. 4 minus 1, 3. So we got 3a cubed. Take that 3a cubed and you're going to multiply that by your divisor, which was 7a plus 3. That right here is 21a to the 4th power. 3 times 3 is 9a cubed. Write that underneath, 21a to the 4th plus 9a cubed. Now again, I like to write it out as it is, and then what I like to do is I like to go back and like physically make sure that I know that I changed the symbols. The first terms will always cancel out. The thing that is remaining should go into your divisor pretty comfortably. If you end up with some weird fraction in the middle of your long division, something went wrong. I'm not going to give you anything, weird. So let's do negative 19, and yes, I'm using a calculator for this, no shame, minus 9, and that didn't work right, so let's try it again. Negative 19 minus 9, there it is. I get a negative 28, a cubed, bring down the next term, and this is very repetitive, as you can see. So then we have negative 28a cubed divided by 7a. We get negative 4a squared. Take that negative 4a squared, write it on top. And we're going to multiply that out. So I get negative 28a cubed minus 12. And again, you guys double check my work and make sure everything's going great and according to plan. I'm going to go back in and physically change my symbols. That goes away. Am I doing it correctly so far? Are we doing good? Double check. I see head nods. Thank you for that. 44 and 12. My anxiety is somewhat kicking in because the numbers are getting larger and larger, so hopefully they'll start getting smaller soon. I mean, not that it matters, it's just, I don't know, my anxiety is kicking in. So we got 56a squared divided by 7a. 56 divided by 7, I get an 8a. So writing 8a here. 8a multiplied by 7a plus 3. we get 56a squared plus 24a. Oh, I like that. I like that a lot. 56a squared plus 24a. Again, I'm going to go in and physically change my symbol so I know. See, but that went bigger again. Okay. That goes away. Negative 25. Am I still good? Even though my numbers are getting large? Okay. Thank you for that. I get negative 49a. Negative 49a divided by 7a, I get negative 7. Negative 7, writing it on top, times 7a minus, just kidding, plus 3. Running out of space, I'm writing it all the way down below. I get negative, forgot to bring down that negative 22. So I get negative 49a. 7 times 3 is 21. I'm going to go back in, change my symbols. That's a plus, that's a plus. Oh, and that's much better. So then I get a negative 1. Are we good with the remainder of negative 1 on that one? Yeah, see head nods, thank you. So please don't write R1 or R minus 1. R should not be in your answer. If you were in 2nd grade, yes, I think that's where we teach you to use R as a remainder. But here in Integrated Math 3, we're going to continue that polynomial in saying this is a minus 1 over 7a plus 3. If you gave me plus a negative, I did accept the answer. It is in correct format. However, it's like adding a negative 3. It's not wrong. It just looks silly. So I gave you that answer as well. All right, beautiful people. That is it. For those of you who wanted 8 and there was another number on the other version, I am available during lunch for tutoring. Stay. It will only take a few seconds, plus your test is tomorrow, so that way I can help you. All right, that is it. Go ahead and start packing up.